Good evening and welcome to the November at Right Angles webinar. This time we are featuring one of my favorite math pedagogical strategies, the low flow, high ceiling pedagogical strategy, which is used mainly for differentiated teaching. And we have with us two teachers, Sai, who is a teacher at Lady Andal School in Chennai. She teaches mathematics to students of classes 7 and 8. Welcome, Sai. We also have with us Malathy, a teacher at DAV Boys Senior Secondary School, Gopalpuram, Chennai, and she teaches math and mental agility to students of classes 4 to 7. So, apart from being math teachers, both of them have a lot of interesting hobbies, and it's been a delight to talk to them and to understand their pedagogical strategies. So, we're hoping to just have a great conversation. I don't have any need to introduce Swati to you all. She's very familiar, and she usually writes the low flow, high ceiling series with me. So great to have you all here, and we will start our webinar. Malathi, I'd like you to start by talking about your adventures while you were teaching fractions. Could we have the PPT on screen, so please? Yeah. Go ahead, Malathi.
So thank you, Sneha. Uh, this is regarding fractions for grade 5, and especially when comparing fractions are there, we have the learning objectives as compare, arrange like and unlike fractions in ascending or descending order, and identify the realized situations where they have to use same. That is the learning objective we have. When we start off, we need the children to know some of the basic things from their previous knowledge. So they are comparing natural numbers, ascending and descending order, basic knowledge of fractions, type of fractions, and equivalent fractions. For comparing fractions, we start with paper strip activity. We'll ask children to bring some same strips, many numbers, so that they can compare using those things. So we will start with unit fractions and like fractions because comparatively they are better, easy to understand. So let me start with like fractions. So when we compare like fractions, the numerators are different, but the denominators are same. So by showing the shaded part, the child or the students will be very easily understand how which is what is more and how much is more. Also, they will be able to understand with the pictorial representation or with the paper folding activities. So here in the picture 1 by 5 and 3 by 5, when the shaded portions are shown, immediately students are very comfortable in saying 3 by 5 is more. The
So,
same
Malathi,
if
just
yeah
one question. Did you give each student the paper strips and did you ask them to divide it?
yeah
Or
each
did you
student
just, yeah.
each student will be bringing I'll just say the A4 size paper, cut it into many strips so that it can be uniform for each and every student.
Okay, okay,
I'll just say
okay.
1.5 centimeters or 2 centimeters. You can get help from the parents to cut it because they might not cut in a perfect way.
Yeah, yeah. Great. Thank you. So they could actually do it and see it and, actually understand for themselves which was greater, 1 by 5 or 3 by 5.
Yes, of course. So the next, it still counts because it's not over with just like fractions. Now we're going towards unlike fractions also. But now with same numerators, now they will be feeling somewhat comfortable with like fractions and slightly moving upon to the higher level. When we say unlike fractions, they blink at us actually. And with same
Hmm.
numerators, then when we show the strips, they will easily understand. So we use the unit fractions here initially. Then other than the numerator 1, we will take. So when 1 by 5 and 1 by 3 is compared, they themselves know that a strip is divided into 5 equal parts and 3 equal parts, and one among that will be more, which is more when they are asked. When they look into the strip, they themselves say that 1 by 3 is more. uh,
Okay.
yeah. The next part is going to be having some other number. So let me take 2 by 7 and 2 by 3. And again, here when we divide exactly, they'll be easily able to understand that 2 by 3 part is more. And I normally compare the chapatis and whatever rotis or something like that, so that the children will easily understand dividing among themselves when some more persons are joining their family. Something like that, when we say, they easily understand the number of items is reduced.
Yeah.
So
Yeah. Have you ever found them getting confused when the whole is of different sizes? Because
uh,
here, when you use the strip, you have ensured that all the strips are the same length.
yeah.
Did
No, they have. I mean, in by mistake, one of the student cut the A4 size in the other way. That is the
Oh,
not in the
great.
portrait. So at that point, he was not able to compare with the neighboring boy.
Ah, though he
So
could
that
compare among his own strips.
he was able to compare among his own strips because everything was same, but he
Yeah.
was not able to compare with the neighboring boy's strip.
Okay, excellent. Look, what a lucky mistake that was. How did you
But
use that opportunity?
yeah, but I said if the strips are of the same size, we can compare. We
Yeah,
should not compare one from the first boy who did it with portrait and the other boy who did it with landscape. That's what I suggested. Then they
great
were
one.
able to understand. Yeah,
Hmm. Shall I move on?
yeah, please. So now, to some extent, unlike fractions are given in a molded way with a positive attitude with same numerators. Now with different numerators, when we jump on, actually they found it very difficult initially, but they were not able to understand after. They were not able to understand before the paper strip activity was given, but after that, with the paper strip or with any drawing work, they were able to do it. So when I
Hmm.
compare 3 by 7 and 4 by 7,
Four
they were
by
able
five.
to, yeah, they were able to identify the shaded part and compare that 4 by 5 is more.
Hmm. Hmm. Hmm.
So three parts out of 7 and 4 parts out of 5, when they compare after shading or coloring, they were able to find it out.
Did they actually say that the numerators was smaller and the denominator was bigger for the smaller fraction? Was there any kind of learning like that, or just as you said, was it only a very visual thing for them?
No, visually they were able to do it.
Oh, okay, okay, okay.
Now, moving on, I generally say that without always we can't have the paper strips with us, so we have to proceed with the normal procedure where we can try it out with some things. I normally divide the blackboard into two parts, one with paper strip and another with the technique.
Mm,
Now when
mm,
I move on to the technique, first is like fractions. So compare only the numerators when it is for like fractions. So we compare the numerators and we say that 5 is less than 7. So 5 by 9 is less than 9. That is what we teach them as technical way.
okay, okay.
Yeah. Then when we move on for unlike fractions, whether it is unit fraction or with same numerators, it is going to be the denominators. If it is becoming more and more, the fraction is going to be less. So I will not start off with proper fractions for this. I go with whole numbers replaced with improper fractions, meaning that 5 by 3, sorry, 15 by 3 and 15 by 5. So we'll
Hmm.
get the answer there as the quotient.
Hmm.
So they will be
Hmm.
easily identifying which number is more.
Hmm. Hmm.
So with that concept, I implement for proper fractions, and they were able to identify that since 11 is less than 13, 8 by 11, when they make as the fraction, that 8 by 11 will become more than 8 by 13.
Okay. Okay. Did they connect back to the paper strip activity?
Yeah,
Okay.
they were able to. Now, with unlike fractions with different numerators, we have so many techniques, and we teach them three important methods, wherein we start with finding the equivalent fractions and making them as like fractions and then compare. So they know the concept of equivalent fractions from class 4, say they were able to identify what are the equivalent fractions. When they find the same denominator, they make as like fractions and then compare. So like fractions comparison is already taught. So they were able to easily identify 6 is more than 5. So 6 by 10 is more than 5 by 10, wherein 6 by 10 is equivalent to 3 by 5 and 5 by 10 is equivalent to 1 by 2.
Wow.
So replacing with the original fraction, we generally insist them. We will not tell that equivalent fraction should be the final answer. So we say that 3 by 5 is greater than 1 by 2, or 1 upon 2 is less than 3 upon 5. Either this way or that way, we will just implement so that the children, some will be more comfortable for less than symbol, some will be comfortable for more than symbol. So we tell them both ways.
Okay. 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 All
Now
right.
going
Then.
for method 2, it is going to be finding equivalent fractions, but the technique is not finding the entire set of equivalent fractions. They use the technique of finding the LCM and then make the equivalent fractions and then compare.
Mm.
So LCM, when they see that if they are co-prime numbers, special cases, they can just simply multiply. We just incorporate some basic knowledges of factors and multiples also over here.
So I like the note because obviously the LCM method, I mean, it is just multiplying 8 and 7 because they are co-prime. Did you also do
Yeah.
examples where one denominator was a multiple of the other
Yes,
or
yes,
they had
yes.
common factors? You also did that.
Yes, yes, yes.
Okay. Okay.
And finally, we just say that the method 3 is the most easiest method. One second.
Malathy?
Sorry, got
Yeah.
slight disconnectivity in audio.
Okay. Okay. Fine.
Uh, so we say that this is the easiest method where fractions, and
Huh.
we say that the technique is multiply the numerator of the first fraction with the denominator of the second fraction, and same way multiply the denominator of the first fraction into numerator of the second fraction, and then compare the result. So 7 11s
Oh.
are 77 and 8 9s are 72. We just compare. So where the side is more, that particular fraction is going to be more. So 77 is more. Actually, this is an indirect way of telling them the LCM method if denominators are co-prime numbers.
Hmm. Hmm. Okay. So now we have your challenges.
Yes. But when paper folding activity was done, they were very perfect.
Huh.
And then when they start working, the first few sums we generally, first sum generally we write on the, as teachers, we write the entire answer on the blackboard.
Hmm.
But when we start reducing our work and making the children do the work on their own, they found some difficulty, or they get confused where we what we have to use and all.
Okay. Okay.
Yeah.
All right. Can we just remove this PPT and let's just talk among the four of us about this really nice activity which Malathy has done. Yeah. So, yeah, I guess Swati, your connectivity is not great, I'm guessing.
Maybe.
Yeah. Okay. All right. Okay. So we saw, I mean, I really, really liked what Malati did with the paper strips. And I can understand when she says the children were perfect when they worked with that because she had chosen her example so well and the concepts were coming out so very clearly. But this is something which, as a teacher, I too have experienced. The minute it moves to the theory part, the children are not really able to connect with it. So what are your comments on that, Swati and then Sai? Swati?
So sometimes when we use pictures to describe fractions,
Hmm.
they get it. But unless we connect it to the math later, it
Hmm.
seems like two different processes and they don't see any interlinkages.
Yeah.
So, all this cross multiplication, etc., they don't get why we do it.
Hmm. So
So,
you're saying that the activity should lead to the rule emerging, is that
yes,
right?
yes, yes.
Okay. Okay. Sai, any comments? You're on mute, by the way.
Yes. What I observed is that something which is similar to what Ms. Swati had to say. How does it all culminate at the end? How do we map the visual activity to something which is as concrete as the operation between two fractions? So, how does it come about? Is it a natural way, or are we uh, are we trying to steer the discussion towards that? So, that is something that we could think about.
Huh. Yeah. Yeah. Swati, do feel free to read out any comments which are coming because
Yeah.
I.
So there are a couple of comments both saying that pictures and strips, etc., they really help activity-based learning. They really help to understand the concept better. And
Huh.
they are from Khachita Ratna
Huh.
and Kirti Bala. And there is one more comment from NRK, which is that the kids understand when she's asking,
Huh.
do the kids understand why we need to do cross multiplication?
Huh.
It's almost technique. It's the most what we teach, and the concept behind technique should also be discussed, which
Yeah.
sometimes we forget to do so.
Yeah. Yeah. uh, I almost want to be sacrilegious and say, do we really need to teach this cross multiplication method? Because up to the equivalent fractions, it makes sense. But the cross multiplication is really like a shortcut. And if it is not making sense, should it actually be taught? I don't know. Anyway, so if we have the PPT on the screen and have you all four join us with the questions that I want to ask, when Malathi, raised this issue, I was thinking of what, as I told you, one of my favorite techniques, whether low flow, high ceiling would help in this case. And so I thought I would make a few low floor, high ceiling activities. And I used some of the resources which Swati had created for Math Space at Azim Premji University. So we will be putting that link on the in the chat box. So if you want to investigate further, but I've just used some images from there. Can we have the slideshow on? Okay. So I started almost exactly as Malathy had, and I compared proper fractions. First, with the denominators equal. The examples I used were from math space, and I was comparing 2 by 9 and 5 by 9. Okay. Here, the strips are deliberately kept together here and separated out. Swati, do you want to say why that is so? Why have the strips been separated out in the second image
So
here?
that you can see there is a one-to-one correspondence between the pieces, and you
Yeah.
can see that one has more pieces than the other.
So it's actually being counted, right?
Correct, correct. While it's the same size piece that makes both fractions.
Yeah, yeah. And here, because it is, the children are not actually making the models, we have the luxury of also having strips and sectors. Okay. It would be difficult for children to create this on the go in class, as Malti was doing, but it is nice to demonstrate both models. And here we have type 2 with the numerators equal 4 by 5 and 4 by 9. Okay, again with strips and sectors. Okay, so we have low flow, high ceiling questions. What are they? Okay, so after the children do this in the class, if you, I am diverging now from what Malti did. Malti did all the types with the strips. Okay, but I'm suggesting that instead of immediately finishing all the activities, it would be a good idea to stop now and ask some questions. And this question is almost exactly what was done in class. Use two strips of equal length to compare 4 by 7 and 2 by 7. So here, what is the difference between what was done in class and what is being asked in this question? What is the only thing that the child has to do? Any response from the three of you all? Okay. Can you all hear me?
Yes, Miss Sneha.
Okay,
Yes.
okay. So the only thing is that earlier, possibly Malti would have said divide it into 7 parts. Now color 4 parts on one strip and 2 parts on the other strip. But here, all I'm doing is checking, can they represent 4 by 7 and 2 by 7 on two different strips of equal length? If they can and they can compare, then I know that whatever activity was done in the class has been understood by them completely. Okay. In the second question, I'm asking a different approach. I'm saying, is 4 by 7 a multiple of 2 by 7? Okay. What I'm doing here is just getting them to taste what is 4 by 7. What is 2 by 7? I'm not just looking at it from the angle of I must represent the fraction, I must compare the fraction. I'm saying this is a fraction and there's another fraction. Can I say that one fraction is a multiple of another fraction? I've deliberately chosen my example like this. And now I say, if you see anything, write down a relationship between them, first in words. Okay. So if they see that if for 4 by 7, they took twice as many parts as for 4 by 7, then I'm actually, good to go with this. All right. And then I think it would be easy for them to write down 4 by 7 is 2 into 2 by 7, twice 2 by 7. Okay. But what I want them to do is not just go directly to the exercise. I want them to understand the meaning of the fraction, to understand the comparison of the fraction. Okay. Here's my next question. Can you use the same strips to compare 3 by 7 and 5 by 7?
Shall I?
Yes.
The same strips, when 2 by 7 is there, I can just shade one more and say it is 3 by 7, and take 4 by 7 strip and shade one more and say 5 by 7. I have done it.
Oh, lovely. Okay. So that is how Malathy would do it. What she's saying is, I will take 1/7 more on either side. Okay. And because I know that 2/7 is less than 4/7, I will add 1/7 on both sides of the inequality. And I will say that, look, I've shaded 3 parts out of 7 here and 5 parts out of 7 there. And I am able to see that 3/7 is less than 5/7. Okay. You see, by doing this, Malathy has seen that adding the same thing to both sides of the inequality has not changed the inequality. Okay. So this is a lot of bonus learning coming from the simple thing of just adding one more. Anyone else?
Some may reflect, with two examples, some may start reflecting that, the larger numerator has is
Yeah,
the bigger
yeah,
fraction.
yeah. So some may actually just say, okay, I'm not using the 4/7 and 2/7, but I already know that more parts colored means, if there are the same number of parts, more parts colored means that that is the bigger fraction. So they will just say 3/7 is less than 5/7. Anything else? Why is this question saying use the same strips to compare 3/7 and 5/7?
They need not waste the next set of strips.
I
Okay.
also
So, which
noticed
is,
that the 3/7 is one by 7 less than 4/7, but sometimes we have students tell us it is one less than 4/7. That is also something that came up.
yes. Thanks, Sai. Very
Um,
often the temptation is to add one to both sides, not 1/7 to both sides. Okay.
okay, so one of the audience, Anand Bhumi Ahmednagar, has said uncolored parts.
Ah,
There is
that was exactly what I was looking for. Okay, thank you. I'm so glad the audience is participating actively. If you look at this, when you color 4 parts out of 7, there will be 3 parts unshaded. And when you color 2 parts out of 7, there will be 5 parts unshaded. Okay, so they can not only compare the shaded parts, they can also compare the unshaded parts. And finally, you will see a question which is far beyond fifth standard. Okay. But if they have taken the approach we discussed just now, perhaps they'll be able to do this. Okay. And this is the essence of the low flow, high ceiling questions. Okay. What is different? In a normal class, you give a task. When the first student arrives at the answer, the whole class moves on. So at that point, the class starts having people lagging behind. And then what happens then is that the class goes on, the exercise may be completed, but when the class is over, there are many students who have not gone beyond the first point. Okay. And this is not the fault of the teacher because she has a limited time. She has to complete certain things. Okay. And she has to be there. So, what happens is that if they wait, the more able students get bored, and the slower students are finally give up because they are perpetually trying to catch up. And then they get bored too. Okay. However, yes, I mean, this is something which every teacher feels. I wish I could move at different paces. So, what does a low flow, high ceiling task mean? Okay. Starting very simple. If you notice the first question, it started so simply. The floor is low, indicating that stepping into the math class is easy, inviting, reassuring. Hey, I can do this. I'm very comfortable here. Okay. And then you step up gradually, tune up the difficulty level slowly. And then you aim high. Ensure that the highest level can challenge but not exhaust the more able student. So we actually have everything, something for every student. And in the process, every student is working at their own pace, but there is enough to ensure that the able students are challenged and the other students can get the help they need from the teacher if they are, stuck and cannot go ahead. Just a small hint actually will help. Something else which came out, other things, when we leave it to the students, their interpretations are so wonderful. Like what Malathy said, I will simply add 1/7 to both sides. They're so wonderful that they lead to more learning. Okay. And students actually learn to taste the concept, to understand it better. Okay. So these are the same questions. I'm going to go a little faster because we do have a lot to share with you all. Okay. This was when the numerators were the same. Take two steps of equal length, use them to compare. So as you can see, started exactly the same as the other. Okay. But now, because they have done the previous thing, this has now moved on to becoming a little more attainable. Okay. So this is still going around the same point. But now we see that what we are doing is the activity is leading the students to make the rule. We are not giving them the rule, but having done all this, can they make the rule? And the high ceiling part is make one problem of each type, okay, and give it to your neighbor to solve. So we know that in NEP, problem posing is a very important feature that is emphasized. If a student can make one problem of each type, that means that they know how to classify the types. They know the difference between the types. And if they make a problem and they give it to their neighbor and then they can check the answer, that means that they have really understood the concept. If they can explain their neighbor's mistake, then you're really on a winning wicket here. Okay. All right. I'm just going to, okay, this is something which we created just for the equivalent fractions. Okay. But in the interest of time, I'm going to stop here and ask if there are any questions. Can we remove the PPT, please?
So there is one question from Ratna. When you asked whether how 2/7 and 4/7 are related, whether that will create any confusion with equivalent fractions.
Okay. How confusion? I'm not very. Oh, you mean like multiplying numerator and denominator and just multiplying the fraction? Yeah, which is why we actually say it in words. You're saying it in words. You're saying you're doubling the fraction. You're saying you're taking twice as many points. Okay, it's when they taste it in words that putting it in symbols makes sense to them. It doesn't become a meaningless operation of I'm just going to multiply numerator and denominator by the same thing. You're saying I am taking twice the number of pieces, which is why I am multiplying only the numerator and I'm getting a different fraction. Swati, do you want to add to that?
No.
Okay. Okay. So I think we will discuss the features of more features of low flow, high ceiling after we go on to the percentages bit. Is that fine?
Yeah, sure, sure.
I think we can have just Sai and Swati on the screen.
Yeah, I'm just trying to share. I hope it is coming.
Yes, I can see it, Ms. Swati.
Okay.
Thank you.
Okay, Sai.
So,
So over.
uh, you were saying?
Yeah, over to you.
Right, yeah, thank you. So, this is a lesson plan that is focused for the eighth graders, and they will be exploring percentage increase and decrease in this particular session. Having said that, they will have an introduction about percentages before we begin this session. So, the objective of this session for the learners to understand the percentage increase and decrease and being able to define in the sense how will they be able to communicate it, and they will be able to calculate percentage increase and decrease, and also identify a few real world examples of percentage increase and decrease which is around them. So just taking them through the real life applications of what they've learned in class. Moving on to the inquiry that will happen for this particular learning engagement will be, Shwati, could you move to the next slide?
Um, Let me know when to stop.
Your screen is frozen.
Okay. Is the screen still frozen?
Not yet. Yes, this is good. So, like I mentioned about the three learning objectives, the reason why we have the three learning objectives is basically for them to develop these four strands or criterions that we have as assessment criterions for mathematics in particular, for them to know and understand, for them to be able to investigate the patterns involved while they study percentages. Moving on to how well they are able to communicate their understanding, be it oral, visual, written form, and finally, how are they able to apply the mathematics they've learned in real life context in different situations. Moving on to the learning engagement itself, we start off with a few materials that is required for the inquiry, which is an inquiry prompt, a worksheet, of course, a whiteboard, and a few markers, and calculators. This is in case we need certain learners to get help from the calculator. And introducing the inquiry to the learners, we begin the lesson by showing a visual prompt. Shwati, could you move to the next slide?
Okay. I have moved, but again, I think it's the net connectivity.
Yes, I can see. I see. I can now see the slide. So basically, this will be the learning engagement that the students will be uh, exposed to initially, and they will have questions and comments about the prompt initially, how they can link the bars to the percentages, decimals, fractions, however comfortable they are, whichever form they are comfortable with, and to understand the meaning that it has with respect to some of the real world examples. Some of the learners had connected these prompts to sales tax, increase in salary. So they came up with excellent examples in class when this visual prompt was presented. Followed by this visual prompt, they will have a set of questions, which is basically a worksheet where we have questions for them, which are formulated in words, and they will work with their partners to solve the questions. Of course, this will be an extension of the inquiry that they've done. So at the end of this inquiry, when they understand percentage increase or decrease, could be visually represented, and it can be communicated in different ways. We move on to the typical form of questioning during exams. So they get those set of questions during this engagement. They will be asked to recall what percentages are. We had one question about whether it is out of 100 always, because in this particular visual prompt, we have the bar going beyond 100. So what happens then? So we have some thought-provoking questions during the inquiry when they are solving the questions from the worksheet. And to wrap up the entire session on percentage increase and decrease, we emphasize the importance of understanding percentage increase and decrease in everyday life. Why is it important for us? So we try and elicit responses from the students themselves rather than us giving it out to them. So a little bit of differentiation that I tried during this learning engagement is to uh, to see if those students who are proficient or advanced begin to apply their knowledge by creating additional scenarios with their partners. So having them to come up with different visual representation of the percentage increase decrease concepts, or asking them to extend the application of percentage increase decrease in scenarios that we might not have discussed in the session. On the other hand, when we have students who need extra support, probably there will be a small guided group. So I will support them, is what I had planned. And finally, to wrap up, like I said, we will discuss, we will summarize, we will ask the students about their takeaways from the session. Some of the challenges that I faced during or at the end of this session was, the students did encounter challenges to understand uh, the basic concept of how percentage changes. Why is it changing? How is it changing? And how do we are able to see it visually, but when it comes to numbers, it's quite difficult, is what some of the students had to say. And how do we really apply it in real world scenarios? In addition to that, few learners also had trouble with conversion between fractions, decimals, and percentages. So that was a bit of a struggle there. So these were the few challenges that the students faced, which in turn was also my challenge at the end of this lesson. Yes.
Thank you, Sai. And can we have everybody back now? So, I mean, percentages are everywhere. When it comes to taxes, discounts, they are pretty much GST, everywhere they are there. So,
Marks.
interest, yeah. So, it's very important that they connect percentages to fractions and decimals. So the low floor part is basically to get the sense out of it, and we start with what is a percent, per hundred. So therefore, it's 15% is 15 out of what, and then form the fraction, and then therefore, so 130% will be what? And I think when we go beyond 100%, if students have a good sense of improper fraction, that might help. Otherwise, if everything is, if their sense of fraction is limited to proper fraction, then that might not help here. Okay. Also, it is important to see how fraction and decimal are converted uh, between each other, and that's crucial. Then, of course, this can be tabulated, and the table can be longer than what we have shown here. So this is like the getting the basics first, and also kind of see the pattern. Um, because percentages and decimals, like if you look at the numerals, there should be something that catches your eye, and if we draw our attention to those, that can help quite a bit. The next part is, talking about changes. So let's
Swati,
decipher.
should we bring the PPT onto the screen?
Okay,
We are,
I was hoping the PPT was already on screen. So yes, please.
it's coming on.
So is it there?
No, the screen is blank, so it is not showing.
Okay. Is it showing now?
Yes, it is. It is.
Okay. Okay. So so this is like what I was talking about, the low floor part, where relation between percentage, fraction, and decimals, and then talk about the percentage change. So, it is change, and therefore there is an initial, final, and that we always consider the initial amount is, which is the base, which is considered the whole, based on which the percentage is computed. And once this is there, then you can kind of try to figure out, okay, so 20% increase means the final amount is what percentage of the initial amount. Or if there is a decrease, then the decreased amount is what percentage of the initial amount. Okay. And of course, we can ask a slightly more thought provoking question like, can there be a decrease which is more than 100%? Is that possible? And why? So then we can go into some uh, real life applications. And in the interest of time, I will have to speed up here a bit. So once the notion of profit loss is there, which we are taking here as an example, I mean, this first table, you basically figure out profit loss and you can then calculate the percentage. So this is kind of the low floor part of the application of percentage. Whereas in the next one, the percentage change is given, and using that you have to figure out the rest. So if the cost price is given, which turns out to be the whole, then it is easier. Whereas if it is the selling price which is given, then it may be slightly more difficult, and therefore a slightly higher level. Now, similar explorations can be done with other applications of percentage, and here are just some examples. Obviously, this can be increased, but this gives the students a very holistic picture of what is happening in that whole situation. Not just like, okay, so if you have this and if you have that, which formula to use, but they get a more holistic picture of, okay, this is how the three, four different quantities are interconnected. So if we know some of them, we can figure out the rest. Now, this is kind of getting it into, for the more able students, who who want to try something more challenging. So if there is a percentage increase followed by a percentage decrease, does it remain the same or not? What if the order is reversed? What if it is first a decrease and then an increase? Okay, so we have taken specific examples and then compare, and you can take it to another level, like, okay, so if the changes were di- not the same, if there was a 30% increase followed by a decrease, a 10% decrease, is that the same as 10% increase but a 30% decrease? So what is happening? So the more able students who have grasped the concepts and probably are hopefully are hungry for more can bite into something more mathematical, can abstract out and generalize. So that's what we
Perfect.
had. So I'll stop sharing now, and yeah.
Right. So I think there were some commonalities across both suggested questions. And can you all just say what you noticed about the low flow, high ceiling technique as such? What is there some particular feature that you liked about it? Yes, Malathy.
Sneha, yeah,
Yeah.
I felt that when the low floor, high ceiling is there, all the children were able to do the first or the second question,
Yeah.
and a little more. Maybe if there is a strength of 30, maybe all 30 will try for first and second and will complete it perfectly.
Yeah. Yeah.
And for the third, maybe around 20 boys or 20 students will be able to do it, and
Yeah.
with the help sometimes. The rest children definitely they will complete it.
Yeah.
Fourth question, only the toppers, so-called toppers, or lateral persons will be able to do.
Okay. All right.
The
Yeah. So
level
that is exact.
increase in
Yeah.
the way.
Yeah.
So all the children will have the, or I can say, will gain the confidence of for the particular concept.
Yes. Yeah. Yeah. And does it only help the toppers that they have done something which others couldn't do, or do you think it can help the less able children too? How do you think this will help those who are not able to complete?
I feel instead of thinking about abled and children who are finding it challenging to solve questions, I would want to differentiate it, the same questions, in terms of probably some of the students, some of my students do not enjoy writing, so probably I would give them something which involves technology. So at least they will have, it's not the least, of course, it's a contentment that they have at the end of that session, that they've completed a task. However, it
Yeah.
is not the way that everyone else in the class does. It'll be differentiated for them. However, the question is also different, but they would have done it the way they are comfortable and they are familiar with. Of course, we would want them to go
Oh,
beyond that familiarity and explore risk taking. But I also feel those children who would want that extra motivation to the confidence is when we give them feedback on how they've performed or how they've responded to these questions, because it's
yeah.
important that we emphasize on that when they complete that particular the first question. It is also important for us to mention this is just not low floor, but it's also a little it involves a lot of thinking for them to answer. It
Yeah.
is challenging for them.
Yeah, thank you, Sai. Because, that is exactly it. Very often we are so tempted to say, have you got it, class? And when one or two children say yes, we just move on. But this way, when you have questions like that, you can actually focus on the students who need the help, and you can let the other students go ahead at their pace. So it really helps the children who are struggling, and it helps the teacher because she can now focus her attention on those children without having the quicker ones creating trouble somewhere else. They are also good, well occupied. Yeah, we have some comments. This method helps in student peer collaborative learning. Anyone want to comment on that?
I think that is very helpful because when we group them, I think we can also group them accordingly. When we have children who are able to solve these questions easily, we can have them drive this particular session for the others. It could be that, or maybe I mean, the class is filled with surprises. So maybe we have the other children who find it challenging otherwise, feel the need to lead this session because they're very confident with the first few questions. So they might just enjoy that moment and they would share their approaches. That has also happened. So the way we group them in class can also
There
enable.
is a very, very important question from Gauri Satya, which we absolutely should take.
Oh yes.
Yeah, 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 yeah. But I think maybe Sai can just finish what she was saying, that the way we group them is important, because, but I would suggest that we don't group them the same way every time. There
Yes,
is a
yes, that's very
certain,
important.
yeah, there's a certain learning that they can get from different groups, sometimes by being
Everyone.
in of the same ability, sometimes by having a vertical grouping. Because when a student explains to another student, learning is reinforced, and we should give them the opportunity for that. Justification, questioning, all of these can happen only when there is a thing. So yes, peer learning is really important. But let's move on to Gauri Satya's question. Would you pose all the questions at one or one by one? I have my answer, but Swati, you want to go?
I mean, I would look into it as it varies from class to class and topic to topic. Um, if it
But
is maybe, depending upon where the students are and how well they are, we will probably somewhere, let's say with the percentage example, with the change. Okay. And then if some students are struggling with the conversion, then probably, go one step down and get them to practice those a bit. And
but
sometimes what happens is some students finish early and then you can give them more. One
yeah,
of the things which I have found quite useful is if you have these questions written down as work cards and they are sequenced, then students kind of have a sense like, okay, if I finish this, I go and get the next card. So in
yes,
that case, you don't have to give them all at once. Because if you do give them all at once, that might be a bit overwhelming for some. So you have
yeah,
to do it according to your class and your
yeah.
preparation.
I really like the idea of work cards, because the whole low flow, high ceiling thing is that they shouldn't be waiting for each other, or they shouldn't be trying to catch up with each other. So it is necessary for students to have access to the next level. Okay. But I agree also that giving it all together is a bit overwhelming. Students may not realize that the questions are scaffolded, and that the answer to one question can help them in the next also. They may just rush through and go to the last one at the beginning itself. So giving them in a way that allows the student to finish and move on their own to the next level, I think is the best solution.
Yeah. And we do have another question
Uh-huh.
from Akash Moria on workbooks. Like, do workbooks follow this technique?
Yeah.
Uh,
Yeah, I wish.
Maybe we can create some.
Yeah, but good resources for low flow, high ceiling. We do have, It is called low flow high ceiling, and it is also called low threshold high ceiling. And one good resource is enrich.maths.org. We will post the link in the comment box. You will also find longer low flow high ceiling activities in the at right angles. Many magazines have low flow high ceiling activities in geometry, in counting, in it's so many that we have done, and I'm sure your students will enjoy doing those. Do you want to add anything, Sai, Malathi, Swati?
Give it a
No,
shot.
perfect.
Yeah.
To all who are listening,
I
give it a
feel,
shot.
Yeah. Give it a shot and
I feel
write
when it
about
comes
it
to
and let us know. Yes, Sai, sorry.
right, when it comes about workbooks, I feel this was one task that we did when we had to frame low floor, high ceiling questions. It involved a lot of critical thinking. So I think it'll be great if teachers think about low floor, high ceiling for every activity or every session possible, so that
Really.
it,
Yeah.
it does keep us, engaged before a lesson, and also we kind of have an idea of what type of questions we can expect in a class. Of course, we go prepared, but when it comes to framing these questions, I feel it's a lot of skill building for the teacher as well.
Great. Yeah, it is. It is. But sometimes you just get addicted. And the thing is that you can do this to introduce a concept, to reinforce a concept, to assess the understanding of the concept. So it can be used at different stages of the pedagogy, or sometimes even to motivate a new idea, you know, like what Malathi said about that adding the same thing to both sides of an inequality. Will that always keep the inequality sign reverse? It's something that children can explore. So, and it was completely unthought of. I only thought of the unshaded part, but here Malathi was bringing an entirely new dimension to the thing. So it was great working with both of you all on this. And Swati, of course, my partner in crime for every wicked activity in mathematics. Thank you all. We are at the end of our time. So we will look forward to hearing from you. Do try this and do write to us if you do try it. Our email ID is, as you know, atria.editor@apu.edu.in. atria.editor@apu.edu.in. All right. So we will see you all at the next webinar, possibly. Thank you.
Thank
Thank
you.
you, Sneha. Thank you, Swati. Thank you.